Welcome back to the JakeJoshTeam channel, and today we're continuing on in the near coastal exam practice, and today's subject is going to be comparing the magnetic compass to the standard magnetic compass. Alright, so let's jump into this. So the 2018 near coastal exam question reads such. You swung ship and compared the magnetic compass against the gyro compass to find the deviation. Gyro error is 2 degrees west, variation is 8 degrees west. Find the deviation on the gyro heading of 0, 3, 9 degrees. So the first thing you're going to want to do when you're looking at this problem is you're going to want to identify if they're asking you to find the deviation on a gyro heading or the per standard magnetic compass heading. So gyro heading, you would pull your number from this list under the PGC, and if it's per standard magnetic compass, you would pull it under the PSC number list. And on this problem, you'll be able to recognize it pretty easy because you're going to get a long list of numbers. It's going to say heading, PSC, PGC, and you're going to have a long list of numbers going from like 0, 0, 0 all the way up to 360. So when you start this problem, you want to identify all the unknowns and list them out. So we know gyro error is 2 degrees west, variation's 8 degrees west. The problem is asking for us to find deviation, find that number on a gyro heading of 0, 3, 9 degrees. When you set up this problem, you have to understand the concept of being able to add and subtract west and east degrees. So the acronym that we use is Can Dead Men Vote Twice? C stands for your per standard compass or your per standard magnetic compass. D stands for deviation. M is your magnetic heading. V is variation. And T is your true heading, your true course. And again, this acronym is Can Dead Men Vote Twice? And when you are in these first 5 acronyms here, you subtract western degrees and you add eastern degrees. Once you get true, you can solve for gyro error and per gyro compass, but when you're here, you add western degrees and you subtract eastern degrees. And I'll show you how that works as we continue on in this question. So let's start filling in what we know. We know our gyro error and we know our variation, so we can put those down. So gyro error is 2 degrees west and variation is 8 degrees west. We know we're on a gyro heading of 0, 3, 9. We're going to put our gyro compass heading at the bottom. Now remember, we're continuing to solve for deviation. We can figure out what our magnetic heading is from these equations, and I'll walk you through that here. Okay, so now that we have some knowns, let's figure out what the magnetic heading is with what we know. So like I said, since we're dealing with gyro error and per gyro compass, any degrees that are west are going to be positive numbers, and any degrees that are east will be negative numbers. So we're trying to figure out what true is. So we need the number here, and we need to add 2, because it's 2 west, to get 0, 3, 9. So simple math would suggest that 37 plus 2 plus, because we're at 2 degrees west on the gyro, 37 plus 2 equals 39. So I remember that we're in the gyro error per gyro compass, one number and it's west, one number plus 2 degrees equals 39. Well, 37 plus 2 equals 39. So that's how we know our true heading is 0, 3, 7 degrees. Now we're in the first 5 spectrum. So remember, we're no longer adding west and subtracting east. Now we're subtracting west and we're adding east. So we need a number, and it's west. We need a number minus 8 equals 37. So we can do math. If you do it backwards, 37 plus 8 equals 45. And you can check your math. 45 minus 8 because it's west, equals 37. So we know our magnetic heading is 45 degrees. Great. So now all we need now to solve the problem is the per standard compass. And we're going to find that with the gyro heading of 039 on this list. So we found magnetic heading, now we got to find per standard compass. Well, the question told us the gyro heading is 039. So 039 fits right in between 024 and 054. So we've identified our number. Our number is 039 on per gyro compass. So I always like to make a little dot and put it there. Once you find the numbers you're working with, just erase the rest of the list. Just cross out the rest of the list of the numbers on there. You won't need the rest of the numbers on the list. You're only going to need the numbers in which the number given to you is between. So in our case, 039 is between 024 and 054. Okay, great, so we found the numbers that we're going to use. What's that mean? Well, you got to do a little interpolating. So we know that our gyro heading is 039 degrees. 039 fits in between 024 and 054. What you're going to want to do is you take these two numbers and you want to find the difference between them. So 54 minus 24 is 30. Keep that number marked because that's going to be our denominator. And then what you're going to want to do is you're going to find the difference between your top number and the number given to us in our per gyro. So the difference between 039 and 024 is 15 degrees. So you take the difference, the big difference between these two, and you put it as your denominator, and then you take the difference between your 024 and the number given to us, which is 15, and you make that your numerator. And we're going to do a little cross multiplication. That's why we're setting these up as fractions. So we got 15 on top, 30 at the bottom. Great. Now you come over to per standard compass. You find the difference between these numbers that correlate with these. So the difference between 61.5 and 30.5 is 31. So that becomes, since this is the big number, that becomes your denominator. We're trying to find the number for per standard magnetic compass to put over here so we can find our deviation. So that is x. So x minus 30.5 is still x. So put x on top. And that is how you set up to figure out what the difference is between 0.30.5 and what the actual number is. So you set up your cross multiplication, and then that's how you figure out what x equals. So when you cross multiply these, x equals 15.75 degrees. So that's the difference between 0.30.5 and our dot, and what the per standard compass number is going to be. The difference, not the number. So you take your 15.75 that you got, and you bring it up, and you add it to 0.30.5 to find the difference. So you add those numbers together, and this number right here is going to be 46.25 degrees. That is our per standard magnetic compass. So now you can take that number and put it right here. So now that we have our per standard magnetic compass and we have our magnetic compass, we can find our deviation. So remember, when you subtract numbers, subtract degrees, in the first 5 quadrants, first 5 acronyms, west is minus, east is plus. And we have to get our 46 1/4 down to 45. So 46 1/4 plus or minus x equals 45. Well, to get 46 to decrease, we're going to have to subtract. And if we're subtracting, we know that we're dealing with a western degree with these acronyms. So now we can go 46 1/4 minus 45 equals 1.25. That's the difference between these two. So if we put x as 1.25 degrees west, if it's west, we're allowed to subtract. We take 46 1/4 minus 1 1/4, we're going to end up with 45 degrees. And that's how we get the magnetic compass. So we have this, we plug it in here, one 1/4 west, and now we have solved the problem. So that's how you solve a per standard magnetic compass compared to a gyro heading compass problem. And the big thing to remember is usually you're just solving for deviation, and that's usually what you're trying to find out. So your answers should be relatively low in number. The big thing you got to remember is when you're dealing with the first 5 acronyms of can, dead, men vote twice, all degrees that are west are negative, and all degrees that are east are positive. Once you take the jump from true into your gyro, this is where, from here going down, this is where that flips, that reverses, and west degrees are positive and east degrees are negative. And that's how you solve per gyro compared to per standard magnetic compass problems.